All right, in this explainer, we're taking a deep dive into a really cool paper called Agent Fly, and it tackles one of the biggest questions in AI right now. How can an agent learn from its mistakes without having to do a complete and super expensive retraining every single time? Okay, so let's get right into it. The huge challenge for AI agents today is this idea of continuous learning. I mean, you can't just keep hitting the reset button and starting from scratch every single time an agent needs to learn a new skill. That's not just slow, it's unbelievably expensive. Right now, developers are pretty much stuck between a rock and a hard place. You've got two main options. On one hand, you have these rigid, static frameworks. They're reliable, sure, but they're also kind of dumb in a way. They can't learn anything new. Then, on the other hand, you can do a full fine-tuning of the entire model. And while that's super powerful, it is just computationally massive. It's like sending the AI back to college just to learn one new thing. It's just not practical for real-world, continuous learning. So this paper, Agentfly, it proposes a third way, a much more elegant solution, and it's inspired by a system that you and I use every single day, our own memory. I mean, what if an AI didn't need this constant, expensive retraining? What if it could just learn and adapt simply by remembering what it's done before? And the core idea behind this is something called case-based reasoning, or CBR. Now, the concept itself isn't totally new, but applying it to these huge language models, that's a total game changer. Think about it like this. A mechanic hears a weird noise in an engine. They don't go back and reread every textbook they own, right? No, they think, this sounds a lot like that Civic I worked on last month. They retrieve a past case from their memory and adapt the solution. That is exactly what Agentfly is trying to get an AI to do. So, okay, how do you actually build a memory for an AI? Let's pop the hood on the Agentfly system and take a look at how it turns past experiences into a real, practical tool for learning. At its heart, the system runs on a really simple but powerful two-part loop. First, you have the planner. It gets a task, right? But before it just jumps in and creates a plan, it does something crucial. It checks its memory. This memory is a growing library of past experiences. They call it the case bank. Based on what it finds in there, it comes up with a strategy. Then, step 2, the executor module grabs that plan and uses a whole bunch of tools to actually get the job done. Now, this whole planner executor system is only going to be effective if the executor can actually do stuff in the world, right? And its toolkit is, well, pretty extensive. As you can see from this figure from the paper, it has tools to search the web, to crawl websites for information, to understand images and video, and even to write and execute its own code. So this isn't just a chatbot anymore. It's a real agent that can actively go out, gather information, and operate in the digital world. Okay, so the formal blueprint for this whole thing is what's called a memory-based Markov decision process, or MMDP. And you're looking at the diagram from the paper right here. Let's break this down real quick. A standard decision process just looks at the current situation to decide what to do next. But you'll notice that big M here, that's the game changer. That represents the memory, the case bank we were just talking about. So in this model, before the agent chooses an action, it consults its history of similar past experiences. This means its decision is a mix of both the present moment and its past wisdom. And that is the secret sauce behind its performance boost. So a memory-based approach, it sounds great in theory, right? But does it actually work in practice? Well, the performance benchmarks from the paper are pretty conclusive. The data basically screams yes. Okay, first up, let's look at the JEA benchmark. Now, this isn't your simple question and answer test. JEA is designed to be tough. It tests an agent's ability to handle really complex, multi-step tasks that require actual planning and using a bunch of different tools. And on the hardest level 3 problems, check this out. Agentfly hits over 71% accuracy. That just blows the other leading frameworks out of the water. We're talking about a massive leap forward on tasks that are meant to mimic real-world complexity. And look, it wasn't just a fluke on one test. At the time the paper was published, back in June 2025, Agentfly had actually grabbed the #1 spot on the official Gaia validation leaderboard among all open source frameworks. This table here really puts into perspective just how big its lead was. But for me, this might be the most impressive result of all: how Agentfly deals with stuff it's never seen before. When it's faced with totally new problems, out-of-distribution tasks, its memory gives it a performance boost of almost 10%. This is huge. It proves the system isn't just memorizing answers, it's actually generalizing from its past experiences to solve brand new challenges. And, This ability to learn from past queries also makes it incredibly reliable. Check out the simple QA benchmark, which is all about pure factual accuracy. Agentfly set a new state-of-the-art here. Because it can recall what worked in previous searches, it hits 95% accuracy, beating out other agents that were specifically built for web tasks. The researchers themselves really sum it all up perfectly in the paper's conclusion. They say it right here. This isn't just about building a slightly better agent. It's about finding a scalable and efficient pathway for creating agents that can learn continuously, in real time, without those painful retraining cycles. So, let's wrap this all up. What's the big takeaway here? The main message from Agentfly is that the brute force method of endless retraining, it's not the only way, and it's probably not the best way. By taking inspiration from something as elegant as human memory, we can build agents that have their own long-term memory, this case bank, that lets them adapt and get better over time. This whole approach is way more scalable, way more efficient, and it just might be the path to creating truly generalist AI. It's research just like this, in the Agentfly paper, that's pushing the whole field of AI forward every single day. If you enjoyed this breakdown and want to keep up with more of these deep dives into groundbreaking research, do us a favor and subscribe to VibeDoc on YouTube. And that really leaves us with one final, kind of mind-bending thought to chew on. Agentfly proves an AI can learn from its own unique history. So, what happens when an AI's memory isn't filled with generic data from the internet, but with your unique experiences? Your successes, your failures, your preferences? We're really standing on the edge of truly personalized intelligence. And that, well, that could change everything.